This video is a revision of following the rate of a reaction. Okay, so rate of reaction is affected by 4 factors: concentration, temperature, surface area, and catalyst. In this video, we're going to discuss the effect of concentration and temperature. To follow the rate of this reaction, zinc with sulfuric acid to form zinc sulfate and hydrogen gas, we can measure a few things. We can measure the mass of zinc used up per minute, or we can also measure the volume of H2 gas that is liberated per minute or per second. To follow that reaction, so we can take the reading of the volume of H2 gas, or the mass loss. We take out the zinc and measure the mass per unit time. So maybe like every minute, we will take out the zinc to measure its mass and calculate what is its mass loss. So over time, we'll find that the mass loss increase, or we can see that the volume of H2 increases. Okay, at some point, when the reactants ran out, the limiting reagent runs out, then we'll see that the curve or the graph becomes flattened here. Okay, the more steep a graph is, it means the faster the rate of reaction. If the graph is not so steep, it means that the rate of reaction has decreased. And if it's flat like this, then it means the reaction has stopped. So how do we write an IGCSE short essay question where you want to investigate the effect of concentration, maybe the concentration of HCl here, on the rate of reaction of this equation, this reaction? First of all, you must have a specific known amount, or rather I would say mass or length of magnesium ribbon. So if I'm going to use magnesium ribbon like this picture, I can say the length of Mg ribbon. So that's one way to measure the amount of Mg. So be specific. Don't just say amount, because I don't know what amount. Is it the length? Is it the mass? Or what is it? Is it the volume? So we don't usually measure magnesium in volumes. So we try to be specific here. So length of magnesium ribbon, or we can say mass of Mg. Okay, so if our investigation is on the concentration, the effect of concentration, so let's specify the concentration of this HCl. So you might want to say 1 mole per dm cube, and then you repeat later with 2 mole per dm cube. Okay, the concentration. And the other thing that you must specify is the volume. So these are very important. Okay, there's 2 ways to measure the gas liberated. We can use the gas syringe, or the other method is a measuring cylinder inverted over water. So the gas will come in here. And this method is not a good idea if the gas that that is liberated here, it dissolves in water. So remember, if the gas dissolves in water, we don't prefer this method of using the measuring cylinder inverted over water. So gas syringe should be a more straightforward method to collect the gas. Okay, after this apparatus is set up, so you throw in the magnesium ribbon, and then you replace the bung. Bung here means the stopper here. So when you throw in the magnesium ribbon, you have to immediately replace the stopper here, the bung, and you have to immediately simultaneously start the stopwatch. If you want to know the rate of reaction at every point, so at every half a minute, so a certain interval here, every half a minute, you're going to take the reading from this gas syringe, and you put it in a table like this. Later on, you can plot it in a graph. And you'll see that the beginning of the reaction, the graph is more steep. In the middle, it becomes less steep. And in the end, it becomes flattened like that. When it's steep, it means that the rate of reaction is high. Why is the rate of reaction higher here? It's because the hydrochloric acid was at higher concentration in the beginning. And halfway through, part of it is being used up. And when it's used up, the concentration decreases. So you get a slower rate of reaction. And when it's totally used up, there's no more of it. So the reaction stopped. So then the graph flattens. You can calculate the rate of reaction at any point here by drawing a tangent and calculating the gradient. That's one way to get the rate of reaction there. That's not an average rate of reaction. That is the rate of reaction at that certain point of time. If your research is on, your investigation is on the concentration of the hydrochloric acid, so you need to run another experiment using a different concentration. So maybe 2 moles per dm cube for the second experiment. Okay, there's 2 ways for you to do this. The first way is you record the volume of H2 gas at minute number 4 for both the concentrations, for 1 mole per dm cube and 2 mole per dm cube. So at minute number 4, you're going to take the volume of hydrogen. And the one with the higher concentration is going to liberate more hydrogen gas at minute number 4. The second method, you record the time taken. So how much time will be taken for the reaction to liberate 40 centimeter cubes of hydrogen gas. So the one with a higher concentration is going to take a shorter time to liberate that amount of gas. So you must mention that you repeat with a different concentration. And you must compare the different concentrations. Why does a higher concentration give you faster rate of reaction? So we look at the 2 beakers here, beaker 1 and beaker 2. In beaker 1, there is less of the big acid particles here, and the smaller ones are the water molecules. So the acid particles needs to collide with the magnesium atoms here in order to react. So the more collision, the faster they react, the higher the rate of reaction. So in the first beaker, there's lesser of these acid particles. And look at the second beaker here. There's a lot of these big particles, that's the acid particles. So that's to represent that there's a higher concentration of acid here. So when there's a higher concentration, there's a higher chance that they will collide with each other. There's more frequency of collision, more collisions per unit time. So in that case, it will increase the rate of reaction. However, after some time, a lot of the acid is being used up. So we look at the third beaker here, there's very few acid particles here because a lot of it has been used up. It has reacted with the magnesium, so even the magnesium has reduced here. So there's not much collision left. So that's why the rate of reaction decreased, not enough effective collision anymore. So this is why all the graph shows that in the beginning it's more steep, and then halfway through is less steep, and in the end it stopped. That's because of the difference in concentration. Okay, so if you compare these 2 graphs, I would say that B has a higher concentration and A has a lower concentration. That is for these 2 beakers. So A is to represent this beaker with lower concentration of acid particles, and B has higher concentration of acid particles, so they collide more, and it gives us a faster rate of reaction, especially the beginning, because the concentration was higher in the beginning. What if our research is about to investigate the effect of temperature on the rate of reaction? So to do an experiment on the temperature, what is the effect of temperature on the rate of reaction? We're going to do the same steps as what we did for concentration just now. Do mention all these things, the length or the mass of the magnesium ribbon, the concentration. This time is going to be fixed at only one type of concentration, because this time I'm not going to vary the concentration. I'm going to vary the temperature. Mention how you're going to collect the gas, how you're going to measure the gas with the gas syringe. Mention you're going to use a stop clock or stopwatch to measure the time. You may draw out this apparatus that's shown here, or alternatively, you can use the inverted measuring cylinder over water. Okay, as for this point number 5, so instead of concentration, now it's about temperature. So higher and lower temperature. We know that if we increase the temperature, the rate of reaction will also increase, right? So we're going to record the volume of H2 gas at minute number 4 again. So higher temperature liberates more gas. Okay. Alternatively, record the time taken for 40 centimeter cubes of H2 gas liberated. The higher temperature takes a shorter time. Okay, for point number 6, maybe the first experiment I used room temperature, and the second experiment I raised it to say 45 degrees Celsius. And don't forget to compare. Compare can come in terms of just look at number 5 here. This is the comparison. Why does a higher temperature increase the rate of reaction? In fact, it says here, when temperature increased by 10 degrees Celsius, the rate generally doubles. Okay, why so? Again, it's all about collision. So if we increase the temperature of it, or if we heat up the reaction, so the particles in there will gain more kinetic energy. So imagine all these acid particles, they gain a lot of kinetic energy. They'll move faster, so their movement is faster. They'll move everywhere randomly and collide into each other. So there is more collisions per unit time. Therefore, there's a higher percentage of particles that has the minimum energy, activation energy, or we can say a successful collision. So it means that there's an increase in collision, but maybe not all are successful, but there's also a higher percentage that is successful when we increase the temperature, when we heat up.